Welcome to your second video in lesson 9.3. This lesson is dealing with going back and forth between polar and rectangular. The first video we did the points, and now we're going to talk about equations. Now let's talk about just some common differences. If I give you the rectangular equation of a circle that has a center at the origin, so h and k basically are 0. I'm going to have x squared plus y squared equals 16 if I have a radius of 4. Well, if I'm in the polar system and I have my center at the origin or at the pole, I can just say, fine, r equals 4. That's a lot shorter. Let's see, rectangular. If I gave you the line 2x minus 3y equals 6, now we would probably rearrange that and get it into y equal mx plus b form to get the slope, to graph that, get the intercept. If you're in the polar system, though, that simple line looks like this. It has 6 divided by 2 cosine theta minus 3 sine theta. I think I prefer the rectangular system for that one. But when you're going back and forth between equations, there are a few tricks that you need to know. So let's start first by going polar to rectangular. And I always, remind myself that means I'm going to x and y. I'm getting rid of the thetas. So let's start. Let's see, let's have example 3. I think that's where we are. If I give you theta equals pi over 3. Now you remember from the lesson 9.1 that theta equals any of the angles. That's just a straight line, right? That's just a line. Well, if I give you theta, take the tangent, because you can play with tangent theta, right? So we're going to take tangent of both sides, and then the tangent of pi over 3. Well, you know what that is. 60 degrees, you know that that is square root of 3. And if you don't, you need to memorize those, especially the tangents. All right, and so I've got tangent of theta is square root of 3. Well, tangent theta, remember we're trying to go to x and y. Tangent of theta is y over x. Well, look what you just did. All right, cross multiply there, and you have that y equals square root of 3x. So you just changed this polar equation to this rectangular equation. This is a line, so is this. Okay? That's what we're talking about. You're going to go back and forth. Let's try one more. It's a little trickier. So the example 4. Let's say that r equals 3 cosine theta. Now you know from your lesson 9.2 that that is a circle. Okay? When I want to convert that, I'm going to really just look at this for a minute. Cosine theta is equal to x over r. So let's rewrite that. Let's make that r over 1 is 3x over r. And we did that in the first part of the video. I'm going to throw this in just a minute. Do you remember this? Cosine is equal to x over r, adjacent over the hypotenuse or the radius. That's where that's coming from. Right here. Now cross multiply and see what you have. You have r squared is 3x. And you have a substitution now for r squared. That also goes back to the first video. Right here. R squared is x squared plus y squared. So I'm going to make that substitution, x squared plus y squared equals 3x. You're going to get everything on one side of the equal sign. So we have x squared plus y squared minus 3x equals 0. And you know from your work last chapter, when we did conics, you could complete the square, you could move the 3x over here, you could find out where the center is. That is your answer. You have gone from this polar equation to this rectangular equation. Let's go the other direction. Let's go sum of the rectangular to the polar, which means, remember, we want r and we need a theta. So let's have example 5. I'm going to give you x squared plus y minus 3 squared equals 9. Again, you can tell what that shape is. You know from your conics lesson in chapter 7 that that is a circle. Okay, but we're going to figure out how that circle, what that equation looks like in polar form. So you go back to the equations that we just did in the first video, these equations. We're going to substitute with the x and the y. Here we go. So instead of x squared, I'm going to have r cosine theta, and instead of y, I'm going to have r sine theta. So I still have that squared plus I have this value minus 3 squared equals 9. Now it takes a little bit, but you have to FOIL that out, and you can do that. Let's see. This one will be r squared cosine squared. All right, now this is the one that we're going to have to FOIL out, right? So this will be r squared sine squared. My middle term is going to be a negative 3r sine theta, and I'm going to have 2 of those, so that would be negative 6r sine theta. My last term is going to be negative 3 times negative 3, which is a plus 9. Now I'm going to bring this 9 over right now, so that would be negative 9, and that's going to equal 0. Okay? Combined terms. Let's look at what we have. I see a cosine squared plus sine squared. I know what that is. So if I can combine those and factor out the r squared, that would be really nice. So I'm going to make that go away. So that gives me cosine squared plus sine squared. All I did was factor out that r squared term. This is just still minus 6r sine theta. My 9's have gone away. Now I'm going to see right here, this goes to 1. So I have r squared equals, I'm going to move this 6r sine theta to the other side. 6r sine theta. Now I can take both of them. Do you see how both sides have an r? So if I divide by r right here and right here, that leaves me with r equals 6 sine theta. And yes, you know that that is also a circle from your lesson in section 9.2. That's a circle that's kind of up off the pi over 2 axis, right? Yes, that was a lot more work. It is harder to go from the rectangular to the polar. Let's try one more example. Example 6. 2xy equals 4. That actually is a hyperbola. May not be able to see that yet, but that's okay. Let's look at what we have. All right, so I've got an x and a y, just like what we did up here when we made that substitution. We're going to substitute r cosine theta for x and r sine theta for y. Here we go. That would make this 2 times x cosine theta and why did I put x? See, if we were doing this in class, you would have yelled at me, Miss Reams, it's not an x, it's an r. There we go. All right. That needs to be an r. There we go. Yeah, it looks good. All right, equals 4. So I think I can take this value. Ooh, look at this. All right, if I rearrange this, I've got an r and an r. Ooh, this is going back to some good trig. So that gives me r squared times 2 cosine theta sine theta equals 4. Does this look familiar? From that test you all loved so much in Chapter 5? That is sine of 2 theta. Now look at what we've got. Oh, we are so close. All right, equals 4. So now I can divide both sides by sine 2 theta, and I have r squared equals 4 over sine of 2 theta, but sine of 2 theta in the denominator like that, remember that's a reciprocal function, so I've got r squared equals 4, we don't want to leave anything down there in the denominator, cosecant of 2 theta. That is your answer. Okay? Now, graphing this hyperbola, when you graph anything similar to what we did in section 9.2, when it's got the r squared, you have to graph the positive and the negative square roots. So let me just make a note right here so that you can see this. No, you're not going to have to graph it, and no, I'm not going to give you a calculator on the test, but I want you to practice and see. That would be 2, because I took the square root of 4. So 2 times the square root of, inside it would have 1 divided by the sine of 2 theta. Remember, because there's not a cosecant button, right? And then the second r, I would do a negative 2 on the square root of 1 over sine 2 theta. And that will allow you to see that hyperbola when you want to. All right, when you come to class, we will do more exercises and going back and forth between polar to rectangular and rectangular to polar. Thank you. I'll see you then.